Hi guys, welcome back to my channel. Today we're going to be looking at the projection of vectors. So a projection is a shadow that's being cast by an object. And in this case in particular, we are looking at the shadow that's cast by one vector onto another vector, as we can see here. So we have the vector A that's being shadowed onto vector B. A different or more useful way of thinking about this is how much pull does vector A have in the direction of vector B. So not how much pull does it have on the vector, but how much pull does it have in that same direction as that other vector. So we commonly use these projections in physics. For example, we could use the vector projection when a particle is being pulled by two forces to find the total movement of the particle in a certain direction. This is called the scalar resolute of A onto B. So to find this, we can use the following formula, and we can see here the projection of vector A onto B is given by the unit vector for B multiplied by the vector A. Let's go through an example here. So scalar resolute of A onto B is found by multiplying each of these. So when we do this, we need to make sure that we're doing this in a particular order. So here we have A is equal to 3i plus 4j and B is equal to 6i minus 2j. So for my first problem, I need to find the scalar resolute of B onto A. So this is different to the last question where we were looking at the projection of A onto B. So I'm going to modify that formula slightly. So now since I am projecting B onto A, all I've done is I've just found the unit vector of A multiplied by the vector B. So let's go ahead and let's find that unit vector for A. So we know that if I was to draw a unit vector, so let's say I've got my vector 3, 4, and this is going to be very roughly here what my vector A looks like, then the unit vector is acting in the same direction. So what we need to do is we need to find the length of this line here, or the magnitude of A, and then we're going to divide that through by the magnitude, and that will give us the unit vector for A. So to find that, let's find this unit vector first. So that's going to be equal to the square root of x squared plus y squared. And in this case, we have x is equal to 3 and y is equal to 4. So the magnitude of this line is going to be 5. So now what I'm going to do is I'm going to take my vector A and I'm going to divide that through by 5, and that will give me a vector that will have a magnitude of length 1. So for us, that's going to be 3i plus 4j divided through by 5. And if I was to substitute this into Pythagoras' theorem, this length here would now be equal to 1. Now that we have our unit vector, we can go ahead and substitute that into our formula. Since this is in component form, I'm going to multiply the two x components and add those to the multiple of the two y components. So the projection of B onto A is going to be equal to 2. So for example, if we were talking about the force of a particle, then the force that's pulling in the same direction is going to be equal to 2 newtons. Let's have another go, and again, very similar question, except this time we're going to be looking at the scalar resolute of A onto B. So again, we're going to switch our formula up. My tips for remembering which way the formula goes is that here we have the projection of A onto B, and see how these letters are in the order BA in the formula? Well, that's also how the dot product will work as well. So they'll be in the order BA. So we have our unit vector going first. So now we can go ahead and calculate our unit vector for B. So again, with this vector is 6i minus 2j. So our vector B is going to look something like this. And all we're interested in is we're just interested in the unit vector here. So that's when this length here is equal to 1. So let's go ahead and find the total length from here to here, and then divide B through by that length to find just the unit vector B. So to find this magnitude B, that's going to be equal to the square root of 6 squared plus negative 2 squared. 6 squared is 36, negative 2 squared is 4, so this is going to be equal to the square root of 40. So now I'm going to take my vector B and divide that through by the square root of 40, and that's going to give me 6i over root 40 minus 2j over root 40. Now just note at this point I'm not simplifying because I'm just going to do that right at the end. So now that I have my unit vector for b, I can substitute that into my formula. And since this is in component form again, I'm going to multiply the two x components and then add that to the multiple of the two y components. So here we have our solution of root 10 over 2. And again, if we were thinking about this in terms of a particle, so I was pulling the particle using two different forces, so this is how much effect that A would have in the direction of B. So in other words, this is how much pull the vector for A has in that B direction. So that's how we use vector projections and why we might use them in real life to solve problems. I'll see you guys in the next video.